Hello everyone, myself Swapnil Sir and welcome to complete lecture series on arithmetic progression. Already we have uploaded plenty of the videos on our channel. So if you are interested to see this video, you do check in my playlist, okay? So in my today's video, I'm gonna explain to you all some of the concept from arithmetic progression, and then at the end we go for solving some of the questions from you completely based on arithmetic progression, okay? So without further ado, let's get dive into our today's lecture. First of all, we are going to understand definition, concept of arithmetic progression, and then at the end we go for solving some of the questions. Okay, let's dive into our today's lecture. Let's get started. So in my first point here, in my lecture first point here, so what is the mean of arithmetic progression? Okay, what actually mean by arithmetic progression? Now see that if we have the sequence or any series in the written in some random form like a 1 2 3 4, we can consider this one is also sequence. Okay, so if that sequence get arranged in some specific order, okay, if that sequence get arranged in some specific order and that order are having some of the rule, then we call it as the arithmetic progression or another type of the progression, or we consider it as the sequence. Okay, now see that if that sequence has to be a arithmetic progression, then that means that sequence needs to hold some of the properties. Okay, then we consider it as the arithmetic progression. Now let me explain one of the sequence here. Okay, okay, let me consider like a 1, after that, okay, let me consider first element 1, after that 3, after that 5, after that 7, after that 9, and so on. Okay, I consider this one is the sequence here. Okay, 1 3 5 7 9 and so on, all these type of the numbers here. We can see that the every number preceding number for our next number having some specific difference same. Okay, now we can see in our first term and second term we have some specific ratio common. Okay, now see that if we take 3 minus 1, okay, if we take 3 minus 1, again if we take 5 minus 3, that means what I am doing here, actually I'm just subtracting second term minus first term, second term minus first term, second term minus first term. Okay, similarly do it for the second one here, 7 minus 5, again do it here, 9 minus 7. Okay, now observe this sequence here, all are having equal difference. Now 3 minus 1 we can take it as the 2. Okay, 5 minus 3, 5 negative of 3, we get it at 2 here. 7 minus 5, we get it 2 here. Again 9 minus 7, it is also going to be a 2 here. Okay, now see that the difference between two consecutive terms, it remains same everywhere. Okay, when the difference between two consecutive terms, it remains same, then we consider it as the arithmetic progression. Now see that how easy definition it is here for arithmetic progression. Okay, what the arithmetic progression, it says that if we consider second element minus first element, okay, third element minus second element, means the difference between two subsequent consecutive terms. Okay, if it comes same everywhere in our sequence, then we call it as the arithmetic progression. We call it as the arithmetic progression here. Okay, now actually this one is the definition for arithmetic progression. I explained here with one of the example. Okay, now so to understand arithmetic progression in detail, we have to understand first of all some of the terms. Okay, some of the terms that is useful for our arithmetic progression. Now see that we have first term here as a 1. Okay, first term here as a 1, so we always write first term which is equal to a, which is equal to 1. Okay, so here in our sequence we have first term a which is equal to 1. Now already we have confirmed here, if a this sequence gives us the common difference same for two consecutive terms, that means this sequence represent arithmetic progression. Okay, but in our arithmetic progression we have some of the identities that we need to understand it first. Okay, so in our arithmetic progression we write first term as a which is equal to 1. Okay, Second term you may write a2 which is equal to 3. Third term, now this one is the first term, this one is second, this one is third, fourth and fifth. These are n number of terms available here. Okay, yes. And if all the terms, if we know that last term is here 11, okay, if last term is 11, then we write number of a term. Okay, number of a term here, that a n number of term. Okay, so number of term, we denote it as the n. Okay, number of term we denote it as the n. Okay, now next part, we have first term, total number of a term. After that, common difference. It is one of the important here, common difference. Common difference. Common difference which denoted as the D. Okay, common difference which is denoted as the D here in our arithmetic progression. Okay, now and nth term, if we have total number of a nth term, we write as the Tn as a nth term. Okay, nth term, we denote Tn as the nth term for our arithmetic progression. Okay, these all are the term which we have here, and that this designated as a, n, d and a Tn here. Okay, so this concept, these are the variable we are going to use for our example solving. Now let me write the definition of arithmetic progression. Okay, what actually mean by arithmetic progression? Already I explained everything here, but let me write at one time the definition of arithmetic progression. So what the actual definition of arithmetic progression is, says that if common difference, okay, if the difference of a two consecutive term, it remains same everywhere in our sequence. Okay, if, let me write the definition, if common difference of two consecutive term, any two consecutive term, okay, anything we consider from our sequence, okay, but that term need to be associated with the first and second, second and third, third and fourth, like this. Okay, if a common difference of a two consecutive term, it remain same allwhere. Same allwhere. If a common difference of a two consecutive term, it remains same allwhere, then we call it as the, then we call our given sequence is in arithmetic progression. We call given sequence is in arithmetic progression. Okay, this one is our the definition for arithmetic progression. Okay, the common difference for two consecutive term, it remains same everywhere. Okay, now see that using our arithmetic progression, we have to define nth term for our arithmetic progression. Okay, that means nth term of arithmetic progression and sum of all nth term of arithmetic progression. We all going to see it later part. Okay, now we'll see that in our next slide. I will explain to you all nth term of arithmetic progression. So if I consider a as a first term, okay, if I consider a as a first term, if I consider a as a first term and d as a common difference, okay, if I consider a as a first term and d as a common difference, okay, and by using this we have to build one arithmetic progression that we are going to generate one generalized result for arithmetic progression as a nth term of arithmetic progression and sum of nth term of arithmetic progression. Okay, so we'll see it here. Okay, now so if we have arithmetic progression as a first term as a, okay, then second term, how it comes? When we add a first term with some common difference, okay, when we add some first term with some common difference, we get the second term here. Okay, So second term we can write a plus d here. Okay. Third term, how can we write? A plus d plus d. That means second term plus common difference. We get the third term. That means we have second term here, a plus d. Okay. And their common difference is a plus d. Okay. Let's go for the fourth term. Okay. So that means a plus d again plus d. We get the fourth term. So we can write a plus d plus d. Okay. This one is our third term, and add one common difference of it here. So this one is our first term, second term, third term, fourth term, and so on. These are the n number of terms which are present here in our arithmetic progression here. Okay. Let's go for just simplified form, that we can write d plus d as a 2d. That's we want changes here. Okay. So keep a as it is here. Okay. A plus d also as it is. We cannot add these two numbers, so keep them as it is. So a plus d plus d. Now see that we have 2 times common difference, a plus d plus d. So d plus d is a 2 times d. Okay. So we write here a plus 2 times d here. Again a plus d plus d plus d. Okay. A plus d plus d plus d. That means 3 times d. Then we write a plus 3d here. Okay. And similarly, now we can observe first term a, second a plus d, third term a plus 2d, fourth term a plus 3d, and left next part as a plus 4d. After that a plus 5d. These are the n number of term which present here in our arithmetic progression here. Okay. Now see that this one is the first term. This one is the first term. This one is the first term. This one is the second term. This one is the third term. Okay. This one is the fourth term. And fifth term. Sixth term. And so on. Okay. These are n number of term which is present here. Now generally we denote T1 as the first term, T2 as the second term, T3 as the third term, T4 as the fourth term. Okay. Now see that. Let me change with the change the color here. We can see that T1 here as the first term, T2 here a plus d as the second term. So this one is our first term here. Okay. T1 which is equal to a. Again T2 which is equal to a plus d is the second term. Again we consider here T3 as a third term. Okay. Again we consider here T4 as a fourth term. Again we take T5 as a fifth term, and so on. Okay. Now as we observe, T1 which is equal to a, T2 which is equal to a plus d, T3 which is equal to a plus 2d, T4 which is equal to a plus 3d, T5 which is equal to a plus 4d. Okay. Now take one of the random term here. So I consider T5 which is equal to a plus 4d. Why I am taking here? I have to generate nth number of a term using our given arithmetic progression. Okay. Now see that T5 which is equal to a plus 4d. So try to write 4 in the form of a 5, so we can generate n number of a term. So T5 can be written as a plus 5 minus 1. 4 I have written as 5 minus 1 here. Okay. What I have done here? I written 4 as a 5 minus 1 into d. Okay. Just for our sake of a simplicity. Okay. Now let's go for the next. T5 which is equal to a plus 4d. Let me write T6 also. Okay. So what we have T6 here? T6 I can written as a plus 5d. A plus 5 times d here. Okay. So let me write 5 is in the form of a 6. Okay. So T6 can be written as a plus 6 minus 1 into d. Okay. Now see that T6 I have written a plus 6 minus 1 into d. Okay. Similarly, if we apply nth term, okay, Tn. Okay. Tn, how can we write Tn here? Okay. Let me write Tn here. Tn which is equal to a, it is remain everywhere same. So a I keep as it is. So 6 minus, that means when we have 6 here, we write a 6 minus 1. When we have n here, we write it as the n minus 1 into d as it is here. Okay, this is our nth term. Okay, what is this? This is the nth term. This is our nth term of our arithmetic progression. Okay, Tn, which is equal to a plus n minus 1 into d, which is the nth term of our arithmetic progression. That's it we want here. Now we can see that a can be written as a plus 0 times d. A plus d can be written as a plus 1 times d. A plus 2d can be written as a plus 3 minus 2 into d. Okay, similarly a plus 3d can be written as a plus 4 minus 1 into d. Okay, so that is the conversion of nth term here. Okay, this is the conversion of nth term of our arithmetic progression. Okay, so that's it here for nth term of arithmetic progression. Also after that we have sum of nth term. Okay, sum of nth term. So sum of nth term, Sn can be written as n by 2 into 2a plus n minus 1 into d. Okay, this is the sum of nth term of our arithmetic progression. Here n is a nth term, a is a first term, d is a common difference. Okay, all these terms included here. Again, we can write a relation between nth term and the sum of nth term. Okay, what the relation is here? We can write nth term of our arithmetic progression as sum of nth term minus sum of n term minus 1 here. Okay, this one is our relation between nth term of our arithmetic progression. Okay, with our sum of nth term here. Okay, I hope you all have understood nth term of arithmetic progression. Okay, so even if you found anything difficult here, let me know in comment section. Okay, I will come up with the similar videos. Now let's move for the next part. In our next part, I have considered some of the examples from arithmetic progression here. Okay, so in our first question, we have given sum of n term is given by. Okay, sum of n term is given here in our arithmetic progression. Okay, which is a Sn given. Let me change color. What we have given? Sn, which is equal to 3 times n square plus 5 times n here. Okay, so we have Sn given 3 times n square plus 5 times n. Then common difference of arithmetic progression. What we want here? We want difference of arithmetic progression. We want here common difference for our arithmetic progression. Okay, so common difference for arithmetic progression means, always remember that when we have to find out the common difference for two terms, so what we do actually here, we have to find out the term first. Okay, so if you know the first term, second term, third term, fourth term, fifth term, then it is easier to find out the common difference between these terms. Okay, so already we have given our sequence here is in a arithmetic progression. Obviously their common difference remains same everywhere. Okay, their common difference remains same everywhere. So what our first task is here, to find out any two terms in our arithmetic progression, that means subsequent term. If I found the first term, that means you have to go for the second term. Okay, second term, third term, like a third term, fourth term, then you will get the required answer here. Okay, yes, we know that sum of a first term, okay, sum of only first term. So if I consider a as a first term and the sum of only first term, we get it only first term here. Okay, this one is the easier part to find out the one of the term from our arithmetic progression. So what I said here, I want the one term from our arithmetic progression by using given result. So what we do here now, basically we are going to find out one of the term from our arithmetic progression. Okay, so for finding one of the term from our arithmetic progression, we know that first term, sum of a first term, we can write first term itself only. Okay, sum of a first term means S1. Okay, so S1 can be written as 3 into 1 square plus 5 times 1 here. Okay, this one is the sum of a first term, S1. Okay, S1 means sum of only the first term. That means it is only represent first term. Okay, this is this only gives first term. Okay, this only gives first term. S1 gives only the first term here. Now let's find out the value for S1. 3 into 1 square, it remains 3, plus 5 into 1, it goes to 5 only. So S1, I got it here, 5 plus 3, which is 8 here. Okay, so I got the value for S1, which is the 5 plus 3, it gives us the 8 here. Okay, this is the value for S1. Okay, now I found the value for S1. Let's go for finding a sum of two terms. Okay, sum of two terms, and subtract first term minus sum of first term minus sum of a second term. Then you will get the second term itself. Okay, okay. Now what we do here? We have to find out the sum of two terms here. Okay, as we know that first term, if you are going to find out the sum of two terms, then subtract first term minus sum of two term. You will get the required sum of two terms here. Okay. Let's go for the sum of two terms. Let me change the color. Yes. Sum of two terms. Okay. We want the sum of two terms. Okay. That means S2. Okay. That means S2 means sum of two terms. That means T1 plus T2, or for A plus D here. Okay. Then sum of two terms S2 can be written as, replace En as a 2, so 3 into 2 square plus 5 into 2 here. Okay, 3 into 2 square means 2 square is a 4, 4 3s are 12, so this one is 12 plus 5 2s are 10 here. That means we found the sum of two terms, which is a 22. Okay, this one is the sum of two term, which is a 22 here. Okay, sum of only first term is 8, sum of two terms, which is here 22. Okay, now when we subtract first term minus sum of two terms, okay, first term minus sum of two terms, then you will get the obviously second term. Okay, that means if you want the second term using first term, then what we do, we go for the sum of two terms minus first term. Okay, that means 22 minus first term, which is here 8. Okay, this one is the second term. Okay, yeah, 22 minus 8, we consider it as the second term. Okay, so 22 means it is the sum of two terms here, sum of first term plus second term. Okay, first term plus second term, which gives us a sum of two terms, and we know that the first term already. Then remove first term from our sum of two terms, so you will obviously get the second term here. Okay, so 22 minus 8, we left here with the value of 14. Okay, which is the second term. So I got the value for first term A1 here as the 8, second term A2 here as the 14. Okay, A1 here 8, A2 here 14. When we are going to find the difference between these two terms, like A2 minus A1, then we will get the common difference for our arithmetic progression. Okay, let's go for finding A2 minus A1. A2 minus A1. Okay, this one is the common difference for two terms. So A2 minus A1 means 14 minus 8. Okay, so 14 minus 8, what gives us? Okay, it is only 14 minus 8. 14 minus 8, then it is goes to the 14 minus 4, and it is only 6. Okay, so answer is our common difference D, which is equal to 6 here. Okay, the common difference D, which is a 6, given in our option number C here. Okay, I hope you all have understood. Very easy answer here. We just want the common difference for two terms here. Okay, nothing is difficult. I'm expecting you all have understood. Let's move for the next example. Okay, in our next example, we have given a tree in each year grows 4 centimeter less than. Okay, what we have given? tree is growing every year, but the growing, it is the decrement. Okay, that means every year it grows lesser than our previous year. Okay, that means the sequence we have here, it is a decreasing sequence. Like a decreasing sequence means 3. After that, if we want the decreasing sequence, we consider as a 10, 8, 6, 5, 4, 6, like this type of the terms are coming. Okay, and when we are going to take the common difference between these two terms, always we get the negative term here. Okay, yes, let me solve here. Next step, a tree in each year grows 4 centimeter less than it grew in a previous year. Okay, that means every year it grows less than previous year, 4 centimeter less than previous year. That means we have common difference. Common difference of arithmetic progression. We have common difference of arithmetic progression, which is a minus of 4. Okay. That means every year it grows lesser than previous year. Okay, that means if our measurement of a previous year it is at 0, then next year, or measurement of a previous year is a 0, next year it grows as a negative of a 4. Okay, like if the measurement is 8, then next year it grows as the 4 type 4. Okay, that means we have to remove 4 every year from the height of our tree. Okay, this is the part of first part of question. Next part, it says that if it grew 1 meter in the first year. Okay, that means in our first year the tree which grew 1 meter here. Okay, that means our first term of our given arithmetic progression, we have here 1 meter. Okay, what is the first term? First term here, a as a 1 meter. Okay, but for finding the calculation for our arithmetic progression, we do not want the measurement in a meter, we want the measurement in a centimeter. So conversion of a meter into the centimeter, we have to multiply 100 to our meter, then you will get the centimeter. Okay, so 1 meter into the centimeter, we write 100 centimeter as a 1 meter here. Okay, this is the part here. Okay, then next part of the question, in how many years will it have ceased growing and what be the height then? Okay, then means at what stage the height of our tree which is ceased, that means it completely stopped growing at the some certain point. Okay, and that point we want the specific height for that tree. Okay, so we want here height of the tree when it get completely stopped. Okay, growing completely stopped. So let's go for finding the arithmetic progression first. Okay, so we have given arithmetic progression AP is a -4. First term A, it is given 100 centimeter. Okay, then we want the how many years, that means nth term in our arithmetic progression, we have to find it here. Okay, let's go for finding the nth term of arithmetic progression. Okay, so we have arithmetic progression, standard form for arithmetic progression as Tn. We have the standard form Tn, which is equal to A plus n minus 1 into d as the nth term of our arithmetic progression. Those terms you know it here, substitute here. So first term A here as a 100 centimeter. Okay, A here as a 100 centimeter plus n minus 1. N minus 1, that means we don't know the value for n, that we have to find out the value for n here at how many years, that means we have to find out the value for n, and the common difference d, which is a -4 here. Okay, common difference d, which is a -4. So this is the actual value for Tn. Go for finding the calculation at our next step and simplified our Tn with a simple, take it to the simple steps. So Tn can be written as 100 plus, now see that -4 into n, we write it as the -4 times n. So -4 into -1, we write it as the plus times 4 here. Okay, this is the way to write the Tn. So we can write Tn as 100 plus 4. 100 plus 4, directly write it 100 plus 4, write it as 104 here, okay, and minus 4n. This is the tnth term of our arithmetic progression, which is a 104 minus 4n here, okay, 104 minus 4n. Now let's go for the next step. We have the terms which at how many years that tree will cease completely growing, okay, that means at what point that tree stop growing completely. That means consider that tn as a 0. So if we consider tn as a 0, then you will get the value for en, okay. So if tn as a 0, then we write this term 104 minus 4n, okay, 104 minus 4n. So we write 4n which is equal to 104, okay. Then we write n which is equal to 104 divided by 4, okay. Then we take the value for n, divide with the 4, 4 2s are 8, and after 2 take it here, 4 6s are 24, okay. So n we have here 26, okay. That means we know that after 26 year later, okay, how many years? It means after 26 year that tree stop growing, okay, that the growing of that tree which is completely stop or cease after 26 year, okay. So that is the answer which given in our option number B here, okay. I hope you all have understood this solution. Nothing is difficult here. So which is given in our option B here. Let's move for the next question. Okay, next question is say that which term of arithmetic progression will be the first negative term, okay. So we have given arithmetic progression we have given here, which is a 10, 8, 6 and so on, okay. So if it is arithmetic progression, that means a common difference between every two consecutive terms, it remain everywhere same, okay. That means 8 minus 10 is a negative 2, 6 minus 8 as a negative 2, 4 minus 6 it is also negative 2, okay. This is the common difference between these terms. So what is the common difference? Let me write common difference, okay. Common difference between these terms, consider D as a negative of 2. Why it is negative 2? Common difference, it says that subtract second term minus first term, okay. That means 8 minus 10, 6 minus 10, it gives always negative 2. So we have common difference D, which is here minus of 2, okay, which is the negative of 2. We got the common difference negative of 2 here, okay. And more thing, we want what will be the first of negative term. What will be the first negative term? So we have to find out the first negative term here. Let's go for finding the first negative term. That means it goes as a last term, 8, then 6, then so on. That means at what step it gives us the first negative term here, okay. That means we have first negative term Tn, which is a smaller than 0. When Tn goes to smaller than 0, that means it always gives us the negative term, okay. Think about it. When we have first term is a negative, that means nth term, okay. So nth term it is a negative. That means we write Tn which is smaller than 0 here, okay. So if Tn is a smaller than 0, then put the formula for Tn. Tn can be written as a plus n minus 1. Tn is equal to a plus n minus 1 into D. This goes to smaller than 0 here, okay. So we know that first term we have here a which is equal to 10. This one is the first term for our sequence, okay. It start decreasing, okay. It's decreasing one after step here. So a which is equal to 10 here plus nth term we have to find it out. We don't know the nth term. So n minus 1, and we have common difference minus of 2, okay. Minus of 2, their multiplication, it is smaller than 0 here, okay. So a which is the first term 10, n minus 1 we don't know the nth term, so nth term we have to find it here. So n minus 1 keep as it is. Common difference between every consecutive term which is a D given as a negative of 2. So if you want to verify why the D is a negative 2, so we write the common difference between 8 minus 10, after that 6 minus 8, okay. So see that smaller term minus bigger term, it always gives us the negative 2. This one is also negative 2. Okay, so common difference between all the consecutive term, it goes to the negative 2 here. Okay, so 10 plus minus 2n and minus 1. Okay, so minus 2n. So what I have done here, minus 2 multiplied by first term, minus 2 multiplied by second term. So 10 as it is plus minus 2n, minus 2 into minus 1, which is a plus 2, which is smaller than 0. That means this number of terms which goes to smaller than 0 here. Okay, so 10 plus 2, which is a 12, minus 2n, which is smaller than 0. Okay, take that 12 to the other side. So minus 2n smaller than minus 12. Okay, so minus n smaller than minus 6 here. Okay, so when we have negative to the both side, so multiply negative sign, so that strictly less get into the strictly greater. Okay, so then we write n strictly greater 6 here. Okay, then in our question we want which term of arithmetic progression will be the first negative term. Okay, will be the first negative term. That means all n gives us the value bigger than 6. Now see that what is the possible chances from our option. So our option first, it says that A, which is first option A is a 4, B option B is a 6. Now see that all the value for n which is strictly bigger than 6. Okay, that means we want the value strictly bigger than 6, which how many values are included here, which is a 7, 8, 9, 10 and so on. Okay, these all are the value for n which is bigger than 6. Okay, that means we do not have the value 6 or lesser than 6. So it is all the bigger than 6 means 7, 8, 9, 10. The possible option here in our example, which is a C. Okay, so our option C gives us the 7, which is the correct answer here. Okay, so I hope you all have understood one of the easy question from your previous year question. Okay, let's move for the next example. In our next example, we have given if for an, okay, if for an a sum of nth term given, okay, for arithmetic progression. What we have given for arithmetic progression, okay, sum of nth term given, okay, sum of nth term, which is a n square, okay, sum of nth term, which is a n square plus 7 times n here. Okay, sum of nth term of arithmetic progression, n square plus 7 it is given. So what is the third term? Okay, so we want the T3. What we want here? We want the value for T3. So let's go for finding the value of a T3. Yes, T3 means we can write sum of nth term in the form of nth term here. Okay, so we know that T-nth term can be written as sum of nth term minus sum of n term minus 1 here. Okay, so we can write this one as T-nth term as sum of nth term minus sum of n term minus 1 here. Okay, this one is the Tn. Okay, so and what we want here, third term, that means we want the value for T3. Third term means T3. First term always denoted by T1. Second term it denotes T2. Third term it denotes T3. So what we want? We want the third term means we want T3 here. So replace T3 in instead of n. So T3 can be written as yes sum of a third term minus sum of a third term minus 1 here. Okay, so T3 can be written as sum of a third term keep as it is minus sum of a third term minus 1. That means sum of second term only. Sum of second term. Okay, so this one is the value for third term, T3 as a S3 minus S2 here. Okay, now for finding S3 and S2, use our sum of nth term given in our question. Okay, so what we have here, sum of nth term given. What is sum of nth term? N square plus 7 times n here. Okay, sum of nth term means we want the sum of second term and third term. Okay, the S3 can be written as 3 square plus 7 times 3. Okay, 3 square plus 7 times 3. So 3 square can be written as 9 plus 7 times 3 is a 21. Okay, so which is a S3. So 9 plus 21, we write it as the 21, it goes to the 20. Okay. Sum of 3 terms, we know that, which is a 20 here. Again, we want the sum of 2 terms, S2. So S2 can be written as, replace Cn as a 2 only. So S2 is a 2 square. S2, it is a 2 square plus 7 times, so 2. Okay. 2 square plus 7 times 2. So 2 square, it gives us the value 4. And 7 2s are 14. Okay. 4 plus 14. Which is gives us value 18 here. Okay. Yes. 14 plus 4, which gives us the value 18. Okay. Sum of 2 terms. S2 we have here. 2 square plus 7 times 2 here. Okay. Now substitute all these values in our formula. You will get the required answer. Okay. So S3 minus S2. Okay. 20 minus 18. Okay. N square plus 7 times n. That means we have S3, which is a 3 square plus 7 times 3. Okay. 3 square 9. 7 3s are 21. 9 plus 21, which gives us the value 30 here. Okay. Not a 20. Sum of 3 terms, which is at 30. Let me change the color. Okay. Okay. So we have here nth term. T-nth term means T third term, which is the sum of 3 term minus sum of 2 terms. Okay. Sum of 3 term minus sum of 2 terms here. Okay. Sum of 3 terms, we have here 30 minus sum of 2 terms here 18. Okay. 30 minus 18. So we write total number of a T3 term. Okay. That means third term in our arithmetic progression. 13 minus 30 minus 18, which is the 12. So this one is our required answer given in our option number D, which is a 12. Okay. Sum of 3 terms, that means we have sum of the 3 terms, which is a 30, sum of the 2 terms, which is at 18 here, and their difference S3 minus S2 can be written as a T3. That means we have third term. Okay. We have third term as a T3, which is equal to 12 here. Okay. Let's move for the next example. Okay. In our next example, we have given 12th term of arithmetic progression with the first term is 1 by 2. Common difference is 1 by 12 here. Okay. So first of all, write it down what we have given in our question. Okay. So in our question, we have given first term. Okay. We have given first term A, which is equal to, we have given first term A, which is equal to 1 by 2. Okay. This one is our first term given in our question. Common difference also given. Common, we have given common difference, which denoted by small d. It is also given 1 by 12 here. Okay. Yes. And we want the 12th term of arithmetic progression. Okay. So what we want? 12th term. Okay. 12th term. We want the 12th term here. We want the 12th term here. Okay. 12th term, and it denoted as a T12. Okay. So we want the value for T12. So, and T12 can be written as, Tn can be written as A plus n minus 1 into D. Okay. What is the formula for nth term in our arithmetic progression? A plus n minus 1 into D, which is the nth term of our arithmetic progression. Okay. So T12 can be written as A plus 12 minus 1. Okay. 12 minus 1 into D as a T12th term. Okay. So T12th term also can be written as A plus 12 minus 1 means 11 times D here. Okay. So T12th term of our arithmetic progression, we write A plus 11 times D. Now see that we have first term A, which is a 1 by 2 given already. Common difference 1 by 12, it is also there. Now substitute the value. T12 can be written as first term A, which is 1 by 2 plus 11 times common difference 1 by 12. This one is the common difference here. Okay, now let's go for finding the calculations. Okay, so 1 by 2 plus 11 by 12. So we write this one is the 1 by 2 plus 11 by 12. Make their denominator same for our sake of easy calculations. So multiply 6 to the numerator, 6 to the denominator, 6 to the 12 plus 11 by 12. Take the 12 common, then 6 plus 11 we get is the 17 by 12. Okay, that means T12th term of our arithmetic progression, it gives us the 17 by 12 our required answer here. Okay, so this one is our correct answer, which given in our option number C. Okay, so our option number C, which is correct here in our example. First of all, we have to jot it down what we have given in our question, put it in one place, apply directly formula, you will get the required answer. So we want the T12th term of our arithmetic progression, which gives us 17 by 12 here. Okay. In our next question, we have given 12th term of arithmetic progression with the first term is a negative 20 and common difference is a 4. Okay. So what we have here, 12th term of arithmetic progression. Okay. 12th term means T12th term. Okay. This one is the T12th term of arithmetic progression with the first term given. With the first term, what is the first term we have here? A minus of 20. Okay, and a common difference. Common difference which is a 4 here. Okay, so common difference given 4. First term it is given minus 20. First term always denoted by A and common difference designated by D here. Okay, so first term of our arithmetic progression which is a negative 20 and the common difference of our arithmetic progression is a 4 here, and we want the T12th term of arithmetic progression, and the T-nth term of arithmetic progression, T-nth term of arithmetic progression can be written as A plus n minus 1 into D. This one is the nth term of our arithmetic progression. So replace the value for n as a 12 as we want the T12th term of our arithmetic progression. So T12th term can be written as A plus 12 minus 1 into D here. Okay, so T12th term can be written as A plus 11 times D here. Okay, so I got the T12th term as A plus 11D. Now replace the value for A, which is a minus 20, and a D as a 4. So T12th term can be written as A is a minus 20. Okay, minus 20 plus 11 keep as it is, common difference D as 4 here. Okay, okay, so minus 20, A is the minus 20, keep minus 20 as it is. So 11 4 is the 44. Okay, so 44 minus 20 we get the 24 as a T12th term of our arithmetic progression. Okay, so our arithmetic T12th term of arithmetic progression, it gives us 24. So which given in our option number C. So our option number C gives us the T12th term or 12th term of our arithmetic progression as the 24. Okay, I'm expecting you all have understood the solution. Let's move for the next question. In our next question, we have given arithmetic progression. So it is not mentioned that given series in the form of arithmetic progression, but we have to figure it out whether it is the arithmetic progression or not. Okay, so our first term, which is a 10.0, second term we have 10.5, third term we have 11.0, fourth term 11.5, and so on here. Okay, these are the n number of terms, and we want the 11th term. Okay, 11th term, what we want? 11th term. 11th term means we want the T11. Okay, we want the T11 as a 11th term of our arithmetic progression. Okay, and we know that the nth term of arithmetic progression, we know that Tn can be written as a plus n minus 1 into d. Okay, Tn as a plus n minus 1 into d. In our question, we want the 11th term, means we want the n as a 11th. That means T11 as a plus 11 minus 1 into d here. Okay, 11 minus 1 into d. That means we want the T11 as a plus 10 times d here. Okay, T11 as a plus 10 times d. Now find out the value for a and d here. Okay, using our given sequence. So in our given sequence, we have given a, which is equal to 10.0. We have given sequence a, which is equal to 10.0. Common difference d, that means you have to subtract second term minus first, third minus second, fourth minus third. This way you will get the common difference. Now consider any two consecutive terms, which is a 10.5 second term minus 10.0. Okay, so common difference you get it here 0.5. Okay, so common difference we write here d as a 1 divided by 2, which is our required common difference for our arithmetic progression, d as a 1 by 2 here. Okay, so we have common difference d as a 1 by 2. So put the common difference d here, first term a 10. Okay, so T11 can be written as first term a, which is equal to 10 plus 10 multiplied by common difference, which is a 1 by 2. So 2 5s are 10. So we write 10 plus 5. Okay, that means 11th term of our arithmetic progression, we write it as the 15. Okay, T11, which is equal to 15 here. Okay, so which given in our option number D. So our required correct option here D. Okay, so D is a T11th term of our arithmetic progression, which is a 5 here. Okay, now let's move for the next question. So in our next question, we have given arithmetic progression of a 25. Okay, arithmetic progression of a 25 would be written in it 5, 8, 11, 14, 17, 20 or 50. Okay, so we have to find it out whether can we write 25 in the form of remaining terms. Okay, how many questions remaining till? Okay, only last 3 questions. Yes, now let's go for the next question. Yes, we can see that this one is just only a logical question that we can easily say that can we write 25 as the next term of our arithmetic progression. Now see that first term we have here 5, second it is 11, third it is 11, fourth term is 14, fifth term 17, sixth term 20 and 50 here. Okay, these all are the n number of terms in our arithmetic progression. Now see that every common difference between every term, 5 minus 8, which is a 3, 8 minus 11, which is also 3, 11 minus 14 also 3, 17 minus 14 also 3, 20 minus 17 also 3. Similarly, we get the 20 plus 3 with next term as a 23 here. Next 23 minus 20, we get the next term 23 here. After that next term, which is a 26, 23 plus 3, 26 plus next step here 29 here. Okay, now see that in our arithmetic progression, we have the number 5, 8, 11, 14, 17, 20, 23, 26, 29. But there is no any involvement of a term 25. So it says that our question says that 25 is the part of this arithmetic progression, but it is never possible. So our answer it is here B, which is a false. Okay, so our answer it is false remain. In our next question, in given arithmetic progression series, find the number 5, 8, 11. Okay, and this one is a similar question that we have solved already in our previous part. So I kept it for you all. Now in our last question, if ABC are in arithmetic progression, we have 3 numbers which is in arithmetic progression, and we have to define whether which one of the option is correct here. Okay, so actually this one is the standard form for arithmetic mean. We know that arithmetic mean for 3 terms. Okay, so if I have A, B and C as the 3 terms for arithmetic progression, 3 terms of AP. Okay, 3 terms for arithmetic progression. Then we write their arithmetic mean. Okay, then we write their arithmetic mean as middle term, which is equal to sum of a first term plus sum of a last term divided by 2 here. Okay, that means A plus C divided by 2 here. Take that 2 here, so we write 2B, which is equal to A plus C. This one is the standard form of a arithmetic mean of our given arithmetic progression. So now see that, check it out, which one of the option is correct here. 2B, which is equal to A plus C, which is not given in our option first, not there in option second, and not is there in fourth. So our required option C, it says that 2B can be written as A plus C as our required answer. Okay, I'm expecting you all have understood. If the 3 terms are in arithmetic progression, then we write their mean as a B, which is equal to A plus C divided by 2. Okay, that is the very much important result in our arithmetic progression as a arithmetic mean here. Okay, so I hope you all have understood this solution. Nothing is there. Okay, so that's it here for our today's lecture. So let me recap what we have learned so far till moment. Okay, we have started with the arithmetic progression. We define sequence series in the form of arithmetic progression. Okay, so just to define arithmetic progression, we found here the common difference. When we get the common difference D as a same for every consecutive 2 terms. Okay, that means preceding term, next term minus preceding term, then next term minus preceding term. All these terms, their common difference gives us everywhere same. Okay, it is same everywhere. Then we write our given sequence is in arithmetic progression. After that, we learn here the nth term of arithmetic progression as a Tn, which is equal to A plus n minus 1 into D as the nth term of our arithmetic progression. We have seen A as a first term of arithmetic progression, A plus D as the second term of arithmetic progression, A plus 2D as a third term of arithmetic progression, A plus 3D as the fourth term of arithmetic progression, and dash 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 A plus nth term of arithmetic progression we written here, A plus n minus 1 times D as our arithmetic progression. Okay, these are the n term of arithmetic progression. Then after that, relation between nth term of arithmetic progression and sum of n term of arithmetic progression, we written Tn as a Sn minus 1 here. Okay, after that, sum of n term we written n by 2 into 2A plus n minus 1 into D. This one is the sum of n term of arithmetic progression. That's it, we all learn here in our today's lecture. I hope you all have understood everything from my today's lecture. If you found anything difficult, let me know in my comment section. I will come up with the similar videos. So thank you everyone. Thank you for my today's lecture.